Hi everybody, good evening from my side, and hope you're all doing fine and that you enjoyed Rui's session as I really did. I'm extremely excited to be with you here today. So before we start, just wanted to thank Benny and DataMinds for giving me a chance to present. So today I want to talk about Power BI internals and some best practices to keep your data model size in optimal condition. I believe it's a quite important topic from many perspectives. Therefore, I really hope that you will enjoy the session and get some useful takeaways once we're done. Before we start, let me just briefly introduce myself. My name is Nikola Ilic. I'm originally from Belgrade in Serbia, but since last 4.5 years, I live in a wonderful city of Salzburg in Austria, where I work as a business intelligence developer at company ITSP Services. Living in Salzburg was the reason why I've chosen my nickname Data Mozart. As you probably all know, Salzburg is very famous as a birthplace of Wolfgang Amadeus Mozart. So I was brave enough to use his last name as part of my nickname. And that's why my motto is make music from your data. I'm regularly blogging at data-mozart.com. I'm also pretty active on LinkedIn and Twitter, so feel free to connect if you like. A few more sentences about me. I have multiple year experience working with different data products, predominantly Microsoft Data Platform. Started with SQL Server, then brushed myself with analysis services, multidimensional reporting services, integration services, and most recently, if you consider last 3.5 years as a recent with Power BI, which I'm a big fan of. Privately, I'm a father of 2 kids and through football and Barca fan, as you can conclude looking at the photo on the slide. So what should you expect today from this session? Well, I like to tell the stories, so don't expect a normal session today. I want to tell you a story about a wonderful tool called Power BI. And in my story, you will be a real hero and our villain is the non-optimal data model size. As in most stories, heroes win in the end, so you will see how to overcome challenges brought to us by evil data model and resolve different issues along the road, and finally make your Power BI development a real fairy tale. Therefore, make yourself comfortable, take a seat, grab a coffee or some other refreshment, and listen carefully to my story. So I guess you all know the story about Titanic. If you don't know, you should watch the movie with Leonardo DiCaprio and Kate Winslet. What? You already watched it? Sure, who hasn't? So Titanic was the most powerful, most beautiful, largest ship of all the time. People were in awe looking at this brilliant piece of human's creativity. But Titanic's story ended almost before it started. After only 4 days of voyage from Southampton to New York City, Titanic hardly hit one of the many icebergs in the Atlantic Ocean. At first look, it didn't seem like something that can transform the greatest engineering achievement into a historical tragedy, when more than 1,500 people lost their lives. However, Titanic didn't sink because it hit the tip of an iceberg. The main culprit was under the surface in the cold ocean water, where the largest part of this iceberg resided. So Titanic received the shot without a chance to recover. And now you're probably asking yourself, what on earth story of Titanic has with Power BI? But if we think a little deeper, we can think of Power BI as an iceberg in the cold ocean's waters. So tip of an iceberg is your Power BI dashboard or the report itself. Doesn't that look beautiful, like a snowy mountain straight in the middle of the water and under this awesome blue sky? So all tourists would look with admiration in this piece of art of the nature, and they are making photos and videos and they want to enjoy this beauty. But what they don't know is that the real thing is under the surface. So the biggest and strongest part of this iceberg, which provides stability and steadiness of the visible part. And this part underneath consists of multiple individual but cohesive parts, which enable this above the surface part to stand strong and shine. As I said, there are multiple individual portions down there. If you think for a moment here as a Power BI developer, you will see different concepts, architectures, techniques that makes your Power BI dashboard shine. If you don't understand and apply those concepts on the right, such as data profiling, data modeling, and data shaping in a proper way, your Power BI report will experience the same fate as Titanic. Same applies if you don't dedicate attention to architectures and techniques on the left-hand side. Always keep in mind that all these, but also many more core concepts is what enable your Power BI dashboard to perform in the most optimal way. And therefore, never underestimate the importance of understanding all those invisible things under the surface. Today, we will focus on learning and understanding VertiPaq engine, but you should also spend your time learning other key concepts listed here. In the end, you can create Power BI reports that work without knowing these underlying concepts at all. That's true. But there is a huge difference between Power BI reports that just work and Power BI reports that work efficiently. Now, in order to watch the story, you need to have some skills before you start. For example, you can't read the book in Chinese if you don't know Chinese. So we are talking here about some prerequisites. And in regard to this session prerequisites, I need to stress a few things. First, this is a 300 level session, which means advanced level. So it assumes that you have some, not just basic, but intermediate knowledge and experience with Power BI and data modeling in general. That being said, I expect from you to have at least basic understanding about relational databases, their structure in terms of how the data is being stored in the database, and to be able to distinguish between rows and columns, of course. Understanding knowledge of Power BI is also necessary to follow along, because I will often refer to some things related to Power BI development that I assume you are familiar with. So as we agreed that I'm telling you a story, I mean, we didn't agree, but I hope that you're fine with that. I've intentionally avoided calling this part agenda. Instead, let's think of it as the contents of the book. So what's in for you today? We will learn what is VertiPaq, how VertiPaq stores the data, what kind of algorithms VertiPaq applies to compress the data, and how we as developers can help VertiPaq to build an optimal data model for us. Finally, we will need to leave our book on the shelf shortly, pick our toolbox, go out and get our hands dirty, dig deep under the hood of Power BI. During the demo, I will show you on a real life example how I managed to reduce Power BI data model size by whopping 90% just by sticking with a few basic but extremely important rules that we will talk about today. Okay, here we are. Before we start, just a simple question to you. Have you ever wondered what makes Power BI so fast and powerful when it comes to performance? When I say powerful, I mean it's able to perform complex calculations over millions or sometimes even billions of rows in a blink of eye. Maybe you wondered but couldn't find the proper answer. Perhaps you were just seeing the tip of an iceberg. Therefore, today we will discover what is under the surface of Power BI and how your data is being stored, compressed, queried, and finally brought back to your report. Once we're done, I hope that you will get a better understanding of the hard work happening in the background. Okay, going back to our starting point, what is a VertiPaq? Before I strictly answer to this question, we should mark the line between the row store and columnar databases. VertiPaq is a columnar database. As you can see in this illustration, columnar database stores and compresses data in completely different way compared to a traditional row store database. So columnar databases are usually implemented in large analytical systems as they are optimized for vertical data scanning. That means that each column has its own structure and is physically separated from other columns. Another important distinction in order to understand what is VertiPaq is to understand the difference between formula engine and storage engine. As you can see in this illustration taken from the book Definitive Guide to DAX from Marco Russo and Alberto Ferrari, formula engine accepts the request, processes it, generates the query plan, and finally executes it. Storage engine pulls the data out of tabular model to satisfy the request issued within the query generated by the formula engine. Storage engine works in two different ways in order to retrieve requested data. Today we will talk about this part here called VertiPaq. So VertiPaq keeps the snapshot of your data in memory, in cache memory, and this data snapshot can be refreshed from time to time from the original data source. Frequency of data refresh depends on your specific business scenario. It can be every half an hour, once per day, once per week, once per month. So it really depends on your specific use case. On the other hand, direct query doesn't store any data. It just forwards the query straight to the data source for every single request. We will also talk about direct query today, but without going deep into into details. Let's talk about Formula Engine. So Formula Engine represents the brain of Power BI. As already mentioned, Formula Engine accepts the query, and since it's able to understand DEX and MDX, by the way, but it is out of the scope of this session, it translates DEX into a specific query plan, and that query plan consists of physical operations that need to be executed in order to get results back. Those physical operations can be joins between multiple tables, filtering conditions, or aggregations. It's important to keep in mind that Formula Engine works in a single-threaded way, which means that requests to storage engine are always being sent sequentially. So let's reiterate once more through the whole process that's happening within Formula Engine. First step is that Formula Engine accepts the request, then it processes the request. Next in the line is to generate the plan for this request, and finally it executes the generated query. Once the query been generated and executed by the Formula Engine, storage engine then comes into the scene. Since it physically goes through the data stored within the tabular model, which is a VertiPaq, or goes directly to different data sources like SQL Server, for example, if you are using direct query storage mode, we can think of storage engine as the muscles of Power BI. When it comes to specifying the storage engine for the table, there are three possible options to choose from. First one is in import mode, then direct query mode, and finally dual mode. As opposed to Formula Engine that doesn't support parallelism, storage engine can work asynchronously. Now we will talk about all these three possible options within storage engine. So first is import mode, which is the most common way to store the data when working with Power BI. Import mode is based on VertiPaq, and table data is being stored in memory as a snapshot, and data is being refreshed periodically. Direct query, when using direct query mode, data is being retrieved from the data source at the query time. That's the key thing. So data resides in its original source before, during, and after the query execution. So nothing is being transferred and stored within Power BI itself. Finally, dual mode, it's simple combination of the first two options. So data from the table is being loaded into memory, but at the query time, it can be also retrieved directly from the source. Now let's talk about import mode more in depth. As we drawn a big picture previously, I want to explain in more details what VertiPaq does in the background to boost performance of our Power BI reports. So what's happening when we choose import mode for our Power BI tables? VertiPaq will perform the following actions. It will read the data source and transform data into a columnar structure. Then VertiPaq will encode and compress data within each of the columns. After that, it will establish dictionary and index for each of the columns. Then it will prepare and establish relationships. And finally, it will compute all calculated columns and calculated tables and compress them. So how VertiPaq stores the data? As you may recall from the previous part of our session, two main characteristics of VertiPaq are that VertiPaq is a columnar in-memory database. So VertiPaq applies different types of compression to each of the columns independently. That's important to know. And choosing the optimal compression algorithm based on the values in that specific column. Sorry. Compression is being achieved by encoding the values within the column. But before we go deeper into a detailed overview of different encoding techniques, just keep in mind that this architecture is not exclusively related to Power BI, as in the background is a tabular model which also works in the background of analysis services tabular and Excel Power Pivot. So let's examine now the encoding types which VertiPaq applies in order to compress the data. So first one is a value encoding, then hash encoding or dictionary encoding, and finally a Run-Length-Encoding or RLE abbreviated. Now we will go into more details regarding each of these encoding types. First one is a value encoding, and this is the most desirable encoding type since it works exclusively with integers. Because working exclusively with integers, it requires way less memory than, for example, when working with text values. So how this looks in reality? Let's say that we have a column containing a number of phone calls per day, and the value in this column goes from 4,000 to 5,000. What the VertiPaq would do is to find the minimum value in this range, which is in our example 4000, and set this value as a starting point. Then it will go and calculate the difference between this value and all the other values in the column, storing this difference as a new value. If you look at this example, you can see that using this technique, we managed to save 3 bits per one row. And at first glance, 3 bits per one row might not look like a significant saving. But just imagine that this table has, I don't know, 100 millions of rows or even billions of rows. And I think you will appreciate the amount of memory saved using value encoding. Hash encoding is probably the most used compression type by a VertiPaq. Using hash encoding, VertiPaq creates a dictionary of distinct values within one column and afterward replaces real values with index values from the dictionary. As you may notice in this example, VertiPaq identified distinct values within the subjects column, then built a dictionary by assigning indexes to those values, and finally stored index values as pointers to real values. I assume, again, I need to repeat this, I assume you're aware that integer values require way less memory space than text. So that's the logic behind this type of data compression. Additionally, by being able to build dictionary for literally any data type, VertiPaq is practically data type independent. And that brings us to one key takeaway. So no matter if your column is of big integer or float or text data type, from VertiPaq perspective, it's the same. So VertiPaq needs to create a dictionary for each of those columns, which implies that all those columns will provide exactly the same performance, both in terms of speed and memory space allocated. Of course, by assuming that there is no big difference between dictionary sizes between those columns. So when someone says to you that data type affects column size, it's a myth. It just affects dictionary size, not column size itself. On the other hand, number of distinct values within the column, which is known as a cardinality, has the greatest impact on your column memory consumption. Finally, third algorithm, RLE, creates kind of a mapping table containing ranges of repeating values, and that way avoiding to store every single repeated value separately. Again, taking a look at the example will help to better understand the concept. In real life, VertiPaq will not store this column start. So I put it here just for the sake of clarity, but VertiPaq is smart enough to just to define where the next node begins just by summing previous values from the count column. So this start column will not exist in reality. As powerful as it might look at first glance, Run-Length-Encoding algorithm is highly dependent on the ordering within the column. So if your data is stored the way you see in our example, like I have here one data bucket with a lot of repeating values, then the second one starts again with a lot of repeating values and another one. So in those situations, RLE will perform great. However, if your data buckets are smaller and rotate more frequently, then Run-Length-Encoding would not be an optimal solution. And one more thing to keep in mind regarding RLE, in reality, VertiPaq applies RLE after hash encoding. So it will first perform hash encoding and create a dictionary of the subjects, like in our example, and then apply RLE algorithm. So the final logic in its most simplified way, of course, would be something like this you can see on your screens. So it's important to remember that Run-Length-Encoding occurs after hash encoding in those scenarios when VertiPaq thinks that it makes sense to additionally compress the data. So when data is ordered in that way, that RLE would achieve better compression than applying hash algorithm only. Let me just briefly iterate through the process of data compression for a specific column. So first step that VertiPaq applies, it scans sample of rows from the column. If the column data type is not an integer, it will look no further and use hash encoding. On the other hand, if the column is of integer data type, some additional parameters are being evaluated. If the numbers in this sample linearly increase, VertiPaq will assume that it is probably a primary key column and choose value encoding. If it works with ranges of values, if the numbers in the column are reasonably close to each other, so number range is not very wide, like in our example with 4,000 to 5,000 phone calls, VertiPaq will use value encoding. On the other hand, when values fluctuate significantly within this range, for example, between 1,000 and 1 million, then value encoding doesn't make sense and VertiPaq will apply the hash algorithm. However, and that's important to remember, no matter how smart VertiPaq is, it can also make some bad decisions. And these bad decisions are based, of course, on incorrect assumptions. So sometimes it can happen that VertiPaq makes a decision which algorithm to use based on the sample data, but then some outlier pops up and VertiPaq needs to re-encode the column from scratch. Let's use our previous example for the number of phone calls, and just imagine that VertiPaq scans the sample and sees the values between 4,000 and 5,000, and VertiPaq chooses to apply value encoding. Then after processing 5 million rows, all of a sudden it found 1 million value. It can be an error or whatever. Now VertiPaq will reevaluate the choice and it can decide to re-encode the column using hash algorithm instead of value encoding. And that would obviously have impact on the whole process in terms of time needed for reprocessing. So here is the list of parameters in order of their importance that VertiPaq considers when choosing which algorithm to use. First one, as already mentioned, is cardinality, so number of distinct values in the column. Then data distribution in the column, which means that column with many repeating values can be better compressed than one containing frequently changing values, because as you already saw, Run-Length-Encoding can be applied on top of hash algorithm. Then number of rows in the table, and finally column data type, which impacts only dictionary size. Few more concepts to understand before we go to demo. So first one is understanding relationships. Once the DAX query being generated by the formula engine, storage engine enters the stage and starts its physical work in order to satisfy the request. So relationships play a big part in this process. They enable quicker transfer of the filter context between related tables. The most important thing to keep in mind regarding relationships is the higher the cardinality of the column that makes part of the relationships, it's the higher cost of that relationship. So when cardinality of the relationship exceeds 1 million, users can notice lower performance in the report. So if you identify relationships within your data model that have cardinality above this threshold, maybe you should start thinking of possible ways to optimize this. One of the reasonable solutions could be creating pre-aggregated tables with different levels of granularity, so you avoid expensive relationships at the query time. Next concept is materializations. Now that we know what are the roles of formula engine and storage engine within tabular model, let's talk about the materialization. So materialization is a step in the query execution process typical for columnar databases. Whenever formula engine sends the query to storage engine will physically go through the data and return uncompressed table that contains requested data. The key word here is uncompressed, and this special temporary storage is called data cache. This temporary storage, this data cache, represents the materialization of the data that will be absorbed by formula engine. And it's important to know that both VertiPaq and Direct Query produce these temporary data cache structures. So you should be aware that there are two types of materialization. Late materialization, which occurs in those situations when storage engine produces one single data cache with exactly the same cardinality as produced by a DAX query. On the other hand, when storage engine generates multiple data caches, or when one data cache has higher cardinality than one generated by a DAX query, we are talking about early materialization. You should tend to achieve late materialization because the main advantage of it is that formula engine gets already prepared data, while with early materialization it needs to perform additional stuff such as joining or aggregating, which implies that the end users can experience slower queries in some scenarios. The key takeaway here is, whenever possible, push most of the workload to storage engine, as that will reduce materialization, and consequentially formula engine would have to cope with less complex tasks. Finally, aggregations. Aggregations are nothing more than reorganized versions of the source table. So you can have multiple different tables related to same original table. By pre-aggregating data on different levels of granularity, we can help storage engine to work faster and scan the data in a more efficient way. Applying different aggregations, we are basically reducing the amount of data, so reducing the number of rows and columns. If you take a look at my example, my raw table contains 7,346 records for chats between July 9th and July 10th, 2017. Now, if I pre-aggregate data and count number of chats per specific subject, my aggregated table will have only 45 rows. So if my users need to analyze data per date and chat subject, having this kind of prepared table in advance will make the storage engine's job much easier, and it can retrieve the data much faster. One important thing to keep in mind regarding aggregations, they don't have any impact on optimization of the complex DAX calculations. They are just enabling storage engine to work more efficient and reduce the time needed to execute the queries. One more important thing to keep in mind, aggregations work only with native columns from your data model. In other words, you can't perform aggregations on calculated columns. In reality, you don't need, of course, to apply aggregations on each fact tables, on each fact table. Aggregations make sense with VertiPaq only for extremely large tables, let's say, for example, few hundred millions of rows or few billions of rows, so not for each fact table. It's not necessary to apply for each fact table. Finally, be careful also when creating aggregation, as each mistake can prove costly, because if not defined in proper ways, aggregations will produce incorrect results in the report. And additionally, having aggregations require additional effort for data model maintenance. Okay, so I believe we laid a solid theoretical background for the things that will come now. And it's time to get our hands dirty and see how all of this works in reality. Before I start, I want to say that this demo is based on a real use case, which I faced during the last year. The problem was with the size of PBIX file on our reporting server, as file size dramatically grown since the report had been introduced. Just to stress one more thing before we proceed further, for the demo I've created 4 separate PBIX files in advance, each of them representing one single phase in the data model size optimization. I did that so we don't need to work on one single file all the time and wait for Power BI to apply the changes we made during the process, as in some cases, as you probably know, it can take a while to reload the data. So let me show you the first. I put just the plain card visual in each of those files showing total number of records in my fact table. So you can see that data accuracy is not being violated by applying different development steps. So I slightly simplified data model. I have my fact table, which contains data about chats performed by our customer support, and I removed some dimension tables. I left only 2 of them. And if I take a look to my fact table, I can see that it has around 9.3 million rows. So it's nothing special in terms of volume. I mean, Power BI should be able to handle this without any problems. The main problem here is that all tables were imported in Power BI as it is, so without any additional optimization or transformation. Just simple check table name and import mode. To be able to follow what is going on with our data model, I will use DAX Studio. For those of you who are not aware, DAX Studio is a fantastic free tool created by Darren Gosbell and Marco Russo and Alberto Ferrari. It has a whole bunch of very handy and useful features that I would need another session just to talk about them. In any case, if you're working with Power BI on a day-to-day basis, you should definitely start using DAX Studio. Believe me, it will make your life much easier. And that being said, I can connect directly from my Power BI desktop. I can connect directly to DAX Studio under this external tools tab. Of course, as a prerequisite, you need to have installed DAX Studio on the same machine as your Power BI desktop. And I will connect directly to DAX Studio. Okay, once I find myself here, just a brief introduction. On the left-hand side, you see all the tables from your data model. If you are curious to know about these tables with strange names, local date table and bunch of some characters, those are hidden date tables created automatically by Power BI. But we will come later to this. I will explain everything in details, I promise. And okay, so one of my favorite features within DAX Studio is a VertiPaq analyzer. VertiPaq analyzer will help us to see different numbers behind our data model. So VertiPaq analyzer tool just collects data from various DMVs in the background. You can also use SQL Server Management Studio to query DMVs and get data about your data model, but you will probably find it in much more readable and understandable form within VertiPaq analyzer. So if I go to Advanced tab and click on View Metrics, it will automatically launch the VertiPaq analyzer, and I can see different metrics related to my data model. So I can see all of the tables within my data model. I can see maximum cardinality of the table, maximum column size, hierarchy size, etc., etc. And the most important thing, if I click on this small arrow next to a table name, I can see all those numbers broken down on a column level. So I can immediately spot which tables are the most expensive one in my data model. One more thing, this column size figure is just a simple sum of those three columns. So data, dictionary, and hierarchy size. Those three values make this total column size. Also, very handy feature, you can see how much space in terms of percentage each of the columns consume in your table. Before we start, let me just show you something. Just a second. Okay, so here is my starting point, 771 megabytes. That's our starting point. And please remember this number, as we will see during the session, how can we optimize this. But what if I tell you that I lied to you? That's not the whole truth. So the truth is even worse. It's not just 771 megabytes. That's just the size of PBIX file. Other than that, some additional things you need to take into account. Additional things like dictionary size. We talked about dictionary while explaining hash encoding, then hierarchies and relationships. Now, if I open this summary tab here, I can see that my whole data model size is 1.86 gigs. So 1.86 gigabytes. That's really huge, and that hurts. And we haven't even interacted with the report. So let's see what we can do to optimize our data model. First thing and starting point always should be to check if you need all the columns in your table. That being said, if I take a look here on my table, I see source ID and chat ID, two columns with highest possible cardinality because they all have distinct values. Chat ID is just a surrogate key from my data warehouse, and source ID is primary key from the source system. So I don't need probably neither source ID, neither chat ID, but let's say that in some cases I need chat ID, I will remove source ID from my data model for the beginning. So let's go to our Power BI desktop, go to transform data, and let's remove from our fact table, let's remove source ID column. So remove column, and I will hit close and apply. Wait a few seconds for Power BI to apply those changes. And now if I again click to view metrics, it will refresh the connection. And if I take a look to summary, I can see that now data model size is 1.54 gigs. So, but by removing just one single unnecessary column, we saved more than 300 megabytes. So let's go back and examine what can be also removed without taking a deeper look. So these two columns, date TM start UTC. One is this date TM start is when the chat started in original time zone, and the second one is just this time converted to UTC. So in any possible scenario, I don't need both of these columns. I will use UTC, and later if I need to do some calculations and manipulate to different time zones, I can do it in report itself. I don't need to import both of those columns, and both of those columns are of date time. Data type goes to a second level precision. Additionally, I was confused with these two columns, referer and session referer. Both have very high cardinality, over 1 million. And I asked my users if they need those columns for any kind of analysis, and I got confirmation that they are not needed. Additionally, last added date is just the information when the record was last time updated in the data warehouse, so not needed at all for any kind of reporting purposes. This one, let me find it. Chat variables, also very expensive column. It's a bunch of JSON records imported as it is. So in any case, if someone needs to do some kind of analysis, this column needs to be transformed in advance before it's imported. So I will go back to my Power BI desktop and remove those unnecessary columns. Again, to transform data. And let's go to fact table and remove those unnecessary columns. So date TM start. Then the next one is referer and session referer. Then what else we said? Chat variables and last added date. Okay, so I will remove all those columns. And let's once again hit close and apply and wait for Power BI to apply those changes to our data model. It will take a few seconds and we will go back to DAX Studio to check the numbers now. So basically we removed 5 or 6 columns, I'm not sure, I think 6 in the end. Okay, take some time. That's why I created separate PBX file, so we don't need to wait for each change to be applied. Okay. So while we are waiting, the first thing you need to do when dealing with the data model size optimization, check the columns in your data model. Probably there are a lot of stuff that you don't need, you or your users don't need in there. So that should be your starting point whenever working with the Power BI data model size optimization. Okay, still waiting. Okay, so it's done. And let's go again to view metrics. And now if we check on summary, it's 660 megabytes. So by just removing few unnecessary columns, we shrink to 2/3 the size of our data model. Just removing a few unnecessary columns. And as I said, that should always be your starting point when you're performing data model size optimization. Why? Let me show you on example to better understand. Let's imagine that you're preparing a delicious dinner for your friends. You invited them for a pizza, but before you make the dish, you have to prepare the ingredients, of course. So what goes into a regular pizza? I would say pizza bread, tomato sauce, ham, cheese. Maybe you need some extra ingredients for some of your guests, such as pineapple or, I don't know, corn or olives, because as a good host, you want to satisfy all your guests' needs. Okay, the next step, you're going into the local shop to buy all you need for your perfect pizza. But while you're walking through the shelves in the shop, you see a beer. Do you need a beer for pizza? I mean, it's always nice to have a beer, but do you need it for the pizza? Few steps more and you spot the chocolate ice cream. I like chocolate ice cream, I really do. But again, do I need it for my pizza? That would be really weird, pizza with chocolate ice cream. So what is the moral of this pizza story? You should focus on those and only those things you really need. Translate it to your Power BI development. You should focus only on data that your report users really need. I mean, you can put something extra, such as pineapples, on top of our pizza in some circumstances when you think that it would bring additional business value to your report or dashboard, but carefully evaluate if that brings more benefit in the final outcome. My question to you is, would you buy a whole pineapple and put it all over your big pizza if you have only one guest eating pineapple pizza and 5 others that don't like this taste? Or should you maybe prepare smaller pizza for this one pineapple guest instead without disrupting the main pizza? I believe that it's always useful to keep in mind this pizza comparison when you are considering which data to put in your data model. Okay, so going back to DAX Studio, hope that you are not hungry after watching these slides. True to be said, in my table there are some more candidates for removal, but let's focus now on some other techniques for data model size optimization. As you may recall from the previous part of our session, when I was talking about the order of importance of different parameters that affects the model size, I mentioned that cardinality is number one. So number of distinct values within the column. The rule of thumb here is the higher the cardinality of a column, so the more distinct values in the column, it's harder for VertiPaq to optimally compress the data, especially if we are not dealing with the integer values. So there are multiple techniques for reducing the column cardinality, and the most popular one is column splitting. I will share with you now a few examples of using these techniques. Let me go to SQL Server Management Studio. So if you're working with integer values, the thing you can do is using division and module operations to reduce the cardinality. How this looks? Instead of having one column with high cardinality, you're getting two columns, one with very low cardinality and one with higher cardinality, but here you have only 3 characters instead of 7. So in a table of few hundred millions of rows, that would bring saving in terms of bits per row. If you're dealing with decimal values, you can split the column before and after decimal point using 2 whole number columns instead of 1 decimal column. That will also reduce the cardinality of the original column. And finally, similar thing can be done if you're dealing with date time values. So you can split this column with high cardinality to 2 columns with lower cardinality. Just one important remark here, if you use the calculated columns to apply data model size optimization techniques, there is no benefit at all, since the original column still has to be stored in the data model first before your calculations take place. Basically, optimization techniques must be performed on the source side. In most cases, by writing a T-SQL statement or within Power Query Editor. So before you import data within Power BI report itself. Of course, if you're writing custom T-SQL code to import the data to your Power BI data model, just keep in mind that you should perform all necessary transformations in your T-SQL logic, as the query folding would be broken if you use custom T-SQL query and afterward apply additional transformation steps in Power Query Editor. Okay, so going back to my next PBX file, because we don't have any decimal values, let's focus on our biggest problem, and that's this DateTM start column, DateTM start UTC column, which has cardinality of almost 9 million, and it occupies almost 90% of the table. So there are multiple valid options to optimize this column. I made a mistake, didn't consult my users, and just remove time part, as I thought, in 95% of cases, their level granularity is completely fine for all the reports. So I just removed time part from my date column. And if I go to DAX Studio from this PBX file, let's see what kind of savings that brought. So going to advanced, view metrics. And now if we go to summary, my data model size is 213 megabytes. So we started with 1.86 gigs and now we are at 230 megabytes. So it's approximately 15% from what we started from. However, it appeared that their level grain was not fine enough and my users needed to analyze figures on our level. Okay, so we can at least get rid of minutes and seconds, and that would also decrease the cardinality of our column. So what I did, I imported values around it per hour. How it's done? You can use dateAdd and datediff function, built-in function in T-SQL. I will show you now how this looks like in reality. So I have my original column, and here I have all my chats rounded to starting hour. Basically, all chats which started between 3:00:00 and 3:59:59 will be rounded to starting hour, which is 3:00:00. And now, if I connect, that's the third file, so rounded to hour level. Let's go to DAX Studio to check if that brought some additional savings. So going to advanced view metrics, and now if we go to summary, it's 221 megabytes. So just 8 megabytes more than in our previous scenario. But this time we satisfied our users' request. So we fulfilled their wish to have data on our level granularity. And if I go now to fact chat table, you may recall that we have almost 9 million cardinality. Now we have 32,000. So, and this column is not so expensive anymore. Looking at this table, one column still bothered me. So that chat ID column, which is just a surrogate key and occupying almost 1/3 of my table. This column is not used in any of the relationships within my data model. Just to be clear, and I don't want you to come into some quick and incorrect conclusions, we can't simply remove all these columns which have ID suffix in the end, like IP address ID, customer ID, product ID. Don't be confused with this part. These columns, IP address ID, customer ID, those are foreign keys to our dimension tables, and therefore they are part of the relationships in our data model. But as I said, chat ID column is just a surrogate key and is not being used in any relationship or calculation. So finally, I removed this column from data model, and I will show you this final PBIX file, going again to DAX Studio. And let's see the numbers now. So if I go to advanced and view metrics, go to summary, it's 161 megabytes. So we started with 1.86 gigs, and now we are at 161 megs. And yeah, I forgot, I promised that we will talk about these hidden tables. So one last step to do is to disable this auto date time in options for data loads. How it's done? You go to File, Options and Settings, Options, and then okay, data load. Here you have under time intelligence, by default, it's checked. Auto date time, it's checked. If you're not aware, if you leave this option checked, Power BI will create a hidden table for every single date field in your data model. So if you have multiple date fields in a table of hundreds of millions of rows, your data model will be bloated with those hidden date tables. What's even worse, these tables search for the minimum and maximum date value in your whole data model and create date range between minimum and maximum value. So if it happens that you have something like December 31st, 2099 for the current records, your automatically created date tables will span until that date, even if you don't have any record in your fact table that matches that date. So yeah, working with dates and importance of having a proper date dimension is a topic for separate session, of course. I just wanted to give you a quick heads up why you should consider disabling auto date time for your Power BI desktop files. And one more time, go to DAX Studio. That's also another hand use case of DAX Studio. You can't see these hidden date tables anywhere in Power BI desktop, but once you connect to your data model with DAX Studio, you can see them. of course, we cannot see them now because we removed them. They are not here anymore. And if I refresh the connection, I can see that I saved additional 4 megabytes. To conclude, I managed to reduce my data model size by almost 90%, applying some simple techniques which enabled the VertiPaq storage engine to perform more optimal compression of the data, or by simply removing unnecessary columns. Maybe some of you now think, wait, Nikola, why did you waste our time with all this blah blah talk about VertiPaq and encoding types and cardinality, etc.? What you just shown us is basically just removal of unnecessary columns, nothing special. And I should admit that you are not completely, but almost completely right. But you also need to keep in mind that in 95% of cases, when you are performing data model size optimization, simple removal of unnecessary or unused columns will be enough to get your job done. And as I already mentioned, but it's never enough repeating this, that should be your starting point when dealing with data model size optimization. In those remaining, let's say 5% of scenarios, maybe even less, you would maybe need to apply some more advanced approaches such as cardinality reduction using some of those techniques I've shown you a few minutes ago. Okay, so to conclude, here is the list of general rules you should keep in mind when trying to reduce your data model size. Keep only those columns your users need in the report. Just sticking with this one single rule will save you an unbelievable amount of space, I assure you. As you've just seen in our demo, sticking with this one rule helped us to make astonishing savings. And always remember PIZZAAA comparison. Try to optimize column cardinality whenever possible. There is no golden rule here. I would say golden rule here is test, test, test. And if you spot significant benefit from, for example, splitting one column into 2 columns or substituting decimal column with 2 whole number columns, then do it. But also keep in mind that your measures need to be rewritten to handle those structural changes in the background in order to display correct results. So if your table is not so big, or if you have to rewrite hundreds of measures, maybe it's not worth splitting the column. As I said, it depends on your specific scenario, and you should carefully evaluate which solution makes more sense for you. Same as for columns, keep only those rows you need. For example, maybe you don't need to import data from last 10 years, but only 4 or 5. That will also reduce your data model size. As you already said, talk to your users, ask them what they really need before blindly put everything inside your data model. Aggregate your data whenever possible. That means fewer rows, lower cardinality, so all nice things we are trying to achieve. If you don't need hours, minutes, or seconds level of granularity, then don't import them. Aggregations in Power BI are very important and wide topic, which is obviously out of the scope of our session, but there are some really awesome resources on the web, and I strongly recommend reading a blog series on creative aggregations from Phil Simark on dex.tips. Avoid using calculated columns whenever possible. Calculated columns, simply said, they're not being optimally compressed. Instead, if you need to do some calculations, try to push all of them to a data source like SQL database, for example, or perform them using the Power Query editor. Use proper data types. For example, if your data granularity is on a day level, there is really no need to use date time data type for these columns. In those situations, plain data type will be completely fine. And finally, disable auto date time option for data loading, as this will remove a bunch of automatically created date tables in the background. That's all from me, folks. Looking forward to hearing your questions.
Okay, thank you, Nikola. That was really interesting. Fast-paced as well, but some really interesting stuff.
Yeah, I tried to put as much as possible.
You have a few questions, so that's good.
Let me scroll to the chat. Okay.
Yeah, I'll just ask him. But Nikki put the comment in that I know as well. Lola wants to know if there are cases where applying dataset size reduction measurements start hurting performance rather than where the trade-off for the decreased dataset size is starting to affect your report performance as well. Do you know any of those cases? And
I'm
I
laughing
anticipate
because
a
yeah,
high
I saw Nikki's
depends.
answer, and yeah, I wanted to start with it depends. Yeah, but that's the only correct start for the answer. It depends on your measures, so of complexity of your measure. In most cases, to be honest, if you are splitting columns, that's for really huge tables, for really huge data models. I would say that those are edge cases when you need to apply those techniques. So it depends on your measure, and again, you need to test it. If you see a significant decrease in performance, then of course you should not apply this technique. But on the other hand, if your data model is close to 1 gig and you have a pro license, so you can't publish this data model because it's greater than 1 gig, then you don't have an other option but to split the column, and yeah, you need to sacrifice the performance in that case. So it's just a trade-off. I would say you need to test and then see and check which solution makes more sense if you have the option to choose. If not, yeah.
I'd say measure it out using DAX Studio. Look at those internals for Formula Engine, Storage Engine, what's happening in there, and measure
Performance
it out.
analyzer and see. Yeah. Correct.
But yeah, very high case of it depends on this question.
Exactly.
Okay, so is there a way to change the default encoding? Because in Tabular Editor, it looks like you can, but it does appear that Power BI doesn't always take these hints into action.
Yeah, I know that there is a possibility to apply a hint, but to be honest, I never did myself that. So I always left Power BI to choose the best possible algorithm.
Yeah.
I know that hints exist, but never use them, so I can't answer to this.
We had a very large discussion about this, I think last week, with some of the MVPs as well, and it boils down to the fact that it's hints, and the engine still chooses
what he
still
wants.
makes the decisions on what the engine thinks is better, and it's not always the case that value is better than hash. So there's actually trade-offs and edge cases where it's better. So Ingmar, reach out to me, and I'll try to dig up the reply that we got on the distribution list and see what I can share with you and whatnot.
Okay.
Yeah, that's also interesting. Yeah.
Could it be that it does the hashing or the encoding based on the top 10,000 values that it gets? And if that's not representative for your entire data set, that you're screwed?
Yeah, there is something to do with that as well.
Sampling can be a problem.
Yeah. But yeah, like I said, reach out and I'll try to see. I'll see what I can share with that and whatnot.
Okay, thanks.
Okay, and then Gert-Jan had a question/comment on the initial question by Lode. Is if we deal with self-service users, doesn't splitting up also introduce the fact that users don't understand because it's not intuitive enough?
Yeah, that's also a kind of trade-off if you have a lot of self-service users. Yeah, that would cause definitely it would cause a confusion between them, but it's not intuitive. Yeah, I agree with that. But as I said, it's really edge case. So in 95 or maybe even more % of cases, you don't need to apply those splitting of columns. Maybe for date and time it makes sense and it is intuitive, but for these integer columns, yeah, it can be counterintuitive. I agree, but again, it's a trade-off. So you need to, or either to instruct users how to cope with that, or just don't do it.
Yeah, no, I agree. I'll share a link in the chat as well, because I know that Gilbert Quevouvier, the guy from Formu, He did some tests with splitting a decimal number into integers and how that changed of his reporting size. But he also does say that because of the fact that you dynamically have to piece them back together in your DAX measures, it's that trade-off that you get where it's where it's not always that easy to start doing it.
Yeah, yeah.
But yeah, that's the entire thing, in my opinion, with shaving off percentages of your data set. At some point, you have to start thinking about how the data set will also be used, and that's what makes it so hard, the data modeling part at all.
Exactly. In the beginning, it's always nice and shiny, because if you have a table with, I don't know, a few 100,000 of rows, it's not a problem to put everything inside. But once your data model grows, and it will grow, of course, during time, yeah, the problems will occur sooner rather than later. Yeah.
But I have to say as well, is when you go start digging into shaving off those percentages, it gets you hooked, and it's hard to stop.
Yeah. Yeah, exactly. Thanks for the links, both to you and Nikki.